So next up is Niclas Skøtt Petersen, hopefully pronounced right. He's going to talk about mastering service sync between Netbox and NSO. So,
thank you.
Welcome. Good luck. They're quite nice, really.
I hope they will be. Cool. Hello, everybody. My name is Niclas. Just spend 30 seconds on me. My name is Niclas. I'm level 27, as I would prefer, as some people like to say it instead. I'm a network specialist in automation at a company called Nordic Fibernet, and a division of Nordic. So my job is to be lazy. And as Bill Gates said, he likes to hire lazy people because they find good solutions. My job is not even only to be lazy, it's actually to be lazy on other people's behalf as well. So that's fun. And outside Nordic, I do a bunch of stuff at festivals, means I know a lot of people in this room from random places. So I won't have time during this talk to go into much depth. So what I will say, and that comes with the warning, is come talk to me after the talk. Because, yeah, I can't go into depth. But I will warn you that I have a tendency to talk a bit. So I spend some time on doing that. So it's at your own warning to come talk to me. So yes. Nordic Fibernet, for the ones in here that don't know, is the Danish largest fiber network. So we operate everything in green with fiber. And all the names you see is also things we operate. But let's not spend too much time on that. My agenda for today is that I'm going to be talking a bit about the background of why I'm doing what I'm doing. And then we're going to go into what the solution is that we are going towards. So yes. So we already passed the intro, so that's good. So, Netbox. Before I explain our Netbox and go into a bit of that, I would like everyone to raise their hand if you use Netbox at your company. Because I have a feeling that's a lot. And I was right. Netbox is a very widely deployed system with many people in the tech community. There are some who also run Autobot, which is also a very good system. There's nothing against that in my view. I've looked at both and used both. But yes. Netbox internally at Nordic started in 2019. So we have some experience using the system. And Netbox with us has developed a lot since we started. You can see on this slide is all the integrations that I have and own for Netbox. Or it's not all even, that's most of the big ones, not all the small ones we have. The ones you can see all the way on the left where you see the D saying DWDM, if you know what you mean internally in Nordic, and OpenNet, those are the ones related to our selling of services to Denmark. Because we are a wholesaler, so we sell circuits to other companies in Denmark. But then you see all the internal systems. And why do we have all these integrations? Well, the integrations have a simple goal. Again, lazy. So I have an engineer, I'll use Cisco ICE as an example. Before we had Netbox and we integrated it with Cisco ICE, every time an engineer created a device, changed an IP on the device, he had to go into Cisco ICE and say, hey, this device has changed IP or it's changed category of device and had all this stuff. But why? And why does he need to do that? Because we already document that in Netbox. So what did I do? I made an integration. So now, whenever a change is made in Netbox, it is within 2 seconds in generic speaking, reflected in ICE. So when an engineer goes into Netbox and says this device has changed its primary IP, duk, it's in ICE. And it works. And that's amazing and it helps efficiency. Because efficiency is the master here. And trying to be efficient with what we do. But what you see here are all supporting network systems mostly. So everything around the network, making it work, the systems around. But what if I want to push the config to the network? And I need data to flow to the network instead of from the network into Netbox. Well, that means we need to look into other things. So traditionally, everyone who implements Netbox, they start with a simple strategy of saying, we have the network here. We're going to take the network and push that data into Netbox. And we're going to be representing our network inside Netbox to show what is going on. And that works very well for a long time. And it did at Nordic as well. We did a lot of this, pushing data into Netbox. But we reached the point of discussion, or reached the point of having a problem. As I mentioned, we have an open net system that talks into our Netbox. It reserves ports on PA devices. If I don't want to divide up my PE into sellable ports and non-sellable ports, I would like them to be just one pool. Well, I need everything to be in sync. So I want to stop this method of going, or its primary will still be validating, but I want the things to flow the other way. So if people document things in Netbox, so an engineer making an MPLS link, he documents it in Netbox before it goes into the network. This means the single source of truth is formed, because Netbox is the single source of truth. You cannot take a port while going into a device, into a PE, and saying, writing a description, reserved for MPS link to this router. No, that is not a thing, and thus does not work with us. You go into Netbox and reserve that port, because that is the source of truth. And that is important for us because we have multiple systems going in and reserving ports in different orders and things. I have other divisions also going in and reserving ports on our devices and provisioning services for them internally. I need everything to be in sync. So this is very important for us to change this workaround for engineers and for the people, for my fellow engineers on the floor, operations say, we need to flip this cycle. Which is saying is flipping the script. Because a lot of people will start with putting data into Netbox. But how do we go on from there? So yeah, this is very important. And the more important thing to mention here is there's no point where we will stop going network into Netbox with validation, checking the data, validating that the data we have in Netbox is correct. And that will still, but correction of that data will be manual. So if someone makes a change in the network that is detected and then shown as a problem in Netbox, someone will have to go in to correct this manually, because we cannot know who is owner if it has not been started in Netbox. So, but with all this, we had a goal, or I had a goal. I wanted to start synchronizing services. And by services, I'm using an NSO term here, but also I want an extractive version of whatever I want on the device. So this could be an MPLS service, it could be a syslog service. It could be anything that needs some information to be published on the device and rolled out. I need to get this from Netbox to the device. And how do we do this? And how do we do this that it's not a specific service, that is a generic way to do this? That is a hard one. So that was not an easy task to solve. But I think we found a good solution, which you will hear more about. But I set up with a goal. I want to sync services to NSO. The first step was, how do I build trust in my engineers? Because my fellow engineers, they're in their habits. There's nothing wrong with that. But I need them to go into a new habit and follow this new habit and trust it. But how do we start that? The way I decided to say is that the first requirement for day one is we should use dry run verification. This means it's still the engineer who rolls out the config. He is just aided in doing his job easier, which means I can build his trust into the system and make him understand what is happening, and he can modify, he can change, he can look at the thing before it rolls out into the network. It's a very nice thing, and it's very much an easier way to start building up that trust into our engineers in this solution. The next thing I wanted is that, while Netbox is very good at storing DSIM and IPAM data, it's not that good at storing a lot of other things. So for the future, wrong order. I will take this one and go back. For the future, I would like to be able to support multiple systems of record. So being able to pull data from a password manager, a Git repo, whatever system I can that has an API that presents data. This is a goal to help this option. The other thing that I jumped over here is that no value should be duplicated, and that's a personal goal. Because values being duplicated inside the system to get it from A to B is more maintenance. And again, I am lazy. I hate doing maintenance work. If I can avoid it, I will do so. So therefore, I will not copy any value. So I'll not put the values from the description of an interface delivers on it lives in NS or it lives in Netbox and it lives on a device. There shouldn't be anywhere really in between. And that's a goal to help and avoid that, because that just means more points of failure along the way. Then I have two kinds of services. I have what I call local services, and I have global or group level services. And again, services are extracted. So in this example here, a local service would be something like an MPLS link. This is specific for a device. This service holds anything that is specifically for one device and one device only. It is not something we deploy on, we have the same options for 100 devices. No, it's a single service for a single device. Then we have group level or global services. These are syslog and all our maintenance stuff and all this stuff that we need to set for 100 or 1,000 devices. I don't want to have to do these individually as local services if I can avoid it. That would be very nice to avoid and very nice, much easier for me to maintain. So, knowing all this, I went in looking for a solution. I had some tools at my disposal. Well, I knew I wanted to use Netbox, so that part was easy. And the network, yeah, that kind of makes it on itself. That's kind of needed in this. So what do I put in between? Well, internally we already use Cisco NSO. And there's nothing in this that you couldn't do this with another system. The reason we have NSO in here is because NSO is very good at abstraction, which means that I can, for, I will say 80% of a service, ignore what OS or platform I'm dealing with. There's of course some stuff I can avoid. A loopback interface on a Juniper and a Cisco, they are named differently. Yeah, I can't avoid that. I will have to document those two differently in Netbox. But how to make them and how to deploy them on different platforms, no. I don't have to deal with that. I will let NSO translate that for me and be my translation layer into multiple OSs, which is very nice and helps me put some of the load or complexity out into different layers of the solution. So that was very nice. But how do we connect these two solutions? So internally, for a lot of the integrations you saw on the earlier slide, we use Python, because Python is, and so far still is, the main automation language for network automation. So if a network engineer goes to look at how can I do a programming solution for a thing, they will most likely find a Python example. So what is there in that market? There is something we use a lot called Fast API. Fast API we use for a lot of our integrations and stuff because it's very easy to get into. There's no complex learning or how to do. So you can take an engineer who's just learned to make a Python script, and within an hour you can have an API that is REST compliant and very nice, has an automatically Swagger file. Everything is quite nice and it's quite easy. And low barrier to entry is a very important thing. And also means that I have more engineers who can help me build this stuff, which is very important for me because I'm not building solutions for me. I'm building solutions for Nordic FiberNet, which means they need to work when I leave too at some point, because I won't be at Nordic forever. So there needs to be somewhere and some solutions that can be taken over by future employees and they can keep being maintainable. Like you heard in the last talk, trying to get code that is maintainable and sustainable over time. Which also means that we're going more and more into internally with more and more people doing Python into code quality, CI/CD, unit testing, all this stuff. But you don't have to do all that from day one. You can start very slowly, you can build an API, it's very simple, and it works very well. The next problem I faced is how do I make users interface with this solution? Well, a lot of engineers would, the first choice they would say is CLI. Give them a Python script or a CLI tool where they can enter in and then it will go do stuff. But I was like, I would like this to be even lower barrier of entry. So, for example, we had 2 new students start recently who are very new IT students. They just got in here from the basic course of the data technician. I would like them to also just could be able to go into this tool and work it. What does that mean? Well, that means the thing I fear at times, a GUI. GUIs. I'm a coder. I'm a back-end engineer. I like to work down in the technical stuff. I can make a GUI. It won't be pretty. It will work, but it won't be pretty and it won't be nice. That is not my area of expertise. And dealing with authentication and front-end authentication, all this stuff for it is not something I want to spend hours upon hours doing. So what do I think? Well, my engineers are already documenting these things inside Netbox. They're already doing a large part of their task inside Netbox. And Netbox has a plugin community where I can make a plugin. Why don't I just make a Netbox plugin? It alleviates both my problems. I can do nice backend code, which I like to do. And then I can leave all the GUI stuff to just copying and pasting how they do things inside Netbox. So it's actually easy for me. And also I can write on the Netbox authentication plugin using that to alleviate all the security concerns. So it's very nice and it gets updated. Any security bug fixes on the how users authenticated, that's handled on the Netbox side. I just do the same thing they do, which means that if I continue to do that, well, then I'm in just as much compliance as the system is. So that's very nice. Now we have all the components of today. But you see here that I don't have any other system than Netbox. And that's because we don't use anything today. But because I have Fast API in this cycle, I can add an integration to whatever system I want that has an API. So our password manager, whatever we would like to integrate. I can add an API call. I can add a support for that inside the tool. And that means data can flow and I can use data from that system in doing my services, which is very nice. And it gives the openness that we want. And Fast API also allowed me to fulfill my goal of no values being deduplicated, because I could do Ginger and some reverse Ginger magic, I won't delve too deeply into, to basically say that I don't have any duplicated values at all. I only have references in config, which you will see an example of later. But to go into the process, and I will go over this quickly to not dive too deeply, but what happens when the user sends a request? They start in the plugin, it goes up to Fast API. Fast API then does a bunch of requesting of data to Netbox. It can do 100 sessions of the requesting data to make it quickly. It's supposed to happen very quickly if I can. And then Fast API goes to NSO. It has assembled the patch request for NSO. It goes to NSO saying, hey, I want to update these services, I want to delete these services, all this stuff happens. And then NSO says, sure, here's a dry run. That goes all the way back to the user in Netbox and is shown. The user then clicks apply, accepts the dry run, and then the whole process runs again. And what ends up happening is everything goes well. The dry run is the same that is expected now. So we push the config out to the network. And then we're good. We've pushed config to the network from Netbox. We've never left Netbox. We've made a whole change inside Netbox. So that's very nice. I think my engineers like it very much at this point. So how does this look in practice? So we have a task. I have a network engineer. He's been told, we need a link between these 2 devices in our lab. And they need 2 times 10G link, an MPLS link between those 2. Can you go make that? Sure. The engineer says that's no issue. He then goes into Netbox, he finds the devices, He then opens each device and finds the ports he wants. He sees, hey, 14 and 15 10 gig ports, they're available on both devices. Means I can make a nice easy task for the engineer or the technician out in the field doing the task, because he can just go 15, 15, 14, 14, easy peasy. That works for the technician as well. The engineer then takes it and goes into Netbox scripts. And if anyone that doesn't know Netbox scripts, it's an internal way of using Netbox and doing things inside Netbox. Yes. We have approximately 20k lines of code inside Netbox scripts to help us do internal things and make things very easy. The engineer takes all this data he has gathered, he figures out the ports and stuff. He enters into this tool that's making an MPLS link. He then executes it. The tool then does a bunch of things. It gathers a lag ID, it gets IPs based on what type of link it is. It does all these things inside to make this very easy. It's very nice. What do we end up with? We end up with an MPLS link, fully documented inside Netbox. And how many steps was that? That was 4 steps? Now we have a fully documented MPLS link, we have IPs, we have everything done for it. We have all the things we need to make the link. What happens behind the scenes, and I talked about the reverse templating and stuff, there's a bunch of data that gets generated by the script that is used to provision stuff. And this helps us get to a finishing point. I won't dive too deeply into this. Come talk to me if you want to know more. The engineer again goes in, he sees the dry run. There's a small page on each device that says, hey, this device is now out of sync, do you want to sync config to it? He then checks the dry run is shown. He then clicks apply up in the corner. And when he does that, it starts running. It goes through the whole process we just saw. When he gets to the end, it says done. I've now deployed config. Cool. We've never left Netbox. What has happened here? Well, if we go into the device, we started with this. 2 admin down ports on the device. What did we end up with? We ended up with a bundled green created interfaces that are configured and up. We ended up with OSPF working as expected. Cool. One small thing here. Did you notice in the task it said documentation? A step we had, and I didn't show this, but how do we do this? In the script there's this line where it creates a long ID, and the ID doesn't matter, it's just an ID. If you use this ID inside our Netbox, you will find the data, everything that is related to the creation of that link has been tagged. So it means you can go pull up a full task for the engineer in one step. Don't need to go in to do 10 things, just one step. So yeah. This is the solution we have today. We're working on this. We're primarily using on our OOB network. We're going to be developing this more, going into things like brownfield strategies. How do we adopt all the existing services? Reconciliation, Alan will talk more about very soon. I won't go too deeply into that, but that's a whole thing. We're going to be adding more services. There are some things I need to work out between NSO and the devices. I'm working with Cisco on. I'm looking at you down there. And we're doing extra integrations to other systems. And then we're looking into compliance. Compliance, I will show one slide on here. One of the things that we're getting once we update the plugin soon is that we're going to get an in compliance or out of compliance thing for each device, which is going to show us if the device is in compliance or not, which is going to help our security folks sleep easy at night, hopefully. So yes. But that was all I had. I now have some time for questions, hopefully.
Thank you very much. We have lots of time for questions because you're early. So,
Good. Thank you very much, Bart with Imperva. So you said speed was important. You like it. From the fast API, you would connect back to Netbox. And I'm assuming you're doing REST calls doing that. Have you tested and looked into using GraphQL to do that?
Yes, or we're going to be looking into more doing crafting a collected GraphQL request. Currently, we're internally in production running an older version of Netbox that doesn't have GraphQL. So right now what I do is just parallelize the calls. So I gather a list of all the data points I need. So if I need interface this, interface that, and I go and gather all that data from Netbox, and then I go get the fields I need from that data. So I do it in multiple operations because the data getting is the hard part. Figuring out what data I need and getting the fields from that data doesn't take any time at all, relatively. I use OpenTelemetry inside these applications, so I follow what part of the application is actually slow. And I was shown that was the Netbox part. Getting the data was always the slow part. Figuring out what I need and figure out the data from that and converting formats and all that stuff doesn't take anything. That is milliseconds. But yes, GraphQL is definitely on the horizon. Yeah, we're definitely going to be looking into that once we upgrade to a version that has it.
Awesome. Thank you.
Any more questions? Great. Party's getting closer. Thank you very much for coming. And
Thank you.